Dalton was considered the father of the atom. Thomson was considered to have discovered an electron. And Rutherford's claim to fame is that he was the father of nuclear chemistry. His experiments led us to an understanding of the atom, and that it had a core or a nucleus to it. So in his experiment, he set up to try and see if J.J. Thomson's idea of the atom was correct. And so his experimental setup was he had a source that he'd read about that produced positively charged particles. And he put this source of positively charged particles inside of a lead block. So he had a lead block, and then he put a hole in the lead block, drilled a hole, and then put this source of positively charged particles inside. And what he got out of this is he got this almost like this gun that shot small positive particles out of it. And then he found a material that glowed every time one of these positive particles hit it. So he placed a screen, circular screen, and this circular screen when the positive particle would come and hit it, it would hit this screen, and then there would be a green flash of light, or a flash of light where it hit, so that he would know, because he couldn't see this beam of positive particles. Later on, these positive particles would be called alpha particles. And before he experimented, he knew that these were really light particles and that they were moving extremely fast, faster than a bullet is moving. And these are actually helium nucleuses, is what they were, but he didn't know that at the time. So this was the beginning of his experimental setup. And what he did or wanted to know was he was going to use these positive particles to be able to figure out what does the atom look like. And so he wanted to put an atom in the way of this positive particle. And he wanted to see, if he shot these positive particles at an atom, whether they would go straight through, whether they would bounce or bend, or whether they would bounce back. And he had a hypothesis before he started, and it was based on the idea of J.J. Thomson's model of the atom, is that since J.J. Thomson had these negative particles embedded inside the atom, that those negative particles would attract the positive charge, but they wouldn't repel them, because the negative attracts positive. So he didn't expect to see any bounce back, and he expected most of them to pretty much go straight through. If they were a positive particle, they wouldn't be impacted too much by a positives or the negatives in there, and they might get deflected a little bit, was what he expected to see. Well, he had to find something that was a one single atom. Well, a single atom is pretty hard to place in front of this beam. And so he decided to find the thinnest material he knew and place it in front of this beam. The thinnest material known to man at that time was gold. So he took a sheet of gold foil and he placed it in the way of this beam. Now, this gold foil, how I'd like you to visualize it at the molecular level, you can think of it as a row of atoms. Now it's a solid sheet, so these atoms are touching. So if you shoot anything at this gold foil, you're going to hit at least one atom. So you know that every time you shoot something, it's going to hit an atom, and so it's got to go through the insides of an atom. And so if anything impacts it, it must have been something that was inside the atom, since gold is only composed of one atom, gold atoms. His results when he did this, he found out that almost 7, and this is an approximation for the material he used. When he used gold, 7,999 of the particles, alpha particles, of 8,000 that he shot or saw went straight through. Now when I say straight through, they could have been deflected a little bit. But for the most part, they went through the atom. And the way that he knew that all of them were going through and not getting absorbed is he counted how many there were in about 10 minutes without the gold foil. And even when he put the gold foil there, the same number went through. So he knew that they weren't getting absorbed. So 7,999 of 8,000 went straight through. Well, if they're all going straight through for the most part, then this supported J.J. Thomson's model of the atom, that, there was some negative particles in here. So the conclusion from this is most of the atom had very little matter. But the part that I want you to focus on, and what's the results that were surprising to Rutherford, were that 1 in 8,000 bounced backwards. Now, this, to me, wouldn't have been a big deal. But the fact that a particle was able to bounce backwards, that's going at the speed of a bullet. Now, the only way that something can bounce backwards is if it's repelled and it hits something that's extremely massive. Well, massive doesn't necessarily mean big. In fact, in this case, since only 1 in 8,000 hit something that was really massive, it means that it's really small. And 1 in 8,000 hitting it, there must be something that's inside of an atom. There's a core that's inside atom that's really small, massive, because it must have a lot of mass to be able to repel this fast-moving bullet, positive charge, and positive. So the reason why they knew that it was small is because only 1 in 8,000 hit it. The reason why they knew that it was positive, the part inside the atom, the core inside the atom that positive particle hit, is because it was repelled backwards. And he saw, when it repelled backwards, that only 1 in 8,000 came back from the screen. Otherwise, all these particles were pretty much going straight through. Now, occasionally, he would have some bend. And that means they got close to this positively charged particle inside the atom. So the way that Rutherford concluded that the atom looked was that there must be something inside this atom that's really small. So it would be this little dot that I've drawn right inside this circle. So that little black dot in there represents this nucleus. core, and that nucleus has a positive charge, and it holds all the mass of the atom. Now, since an atom is neutral and this inner part is positively charged and tiny, that must mean that the negative charges are not in there. Otherwise, it wouldn't be positively charged. The negatives would have canceled it out. So the only model that they had at the time of negative something orbiting was the planetary model. So Rutherford believed that these negative particles were on the outside and they were circling around the nucleus. And these negative particles must have very little mass. So this was the model that he kind of came up with, and this is what we currently think of as the nuclear model of the atom, because it has a core or a nucleus. And all of this idea came about from Rutherford